We started this class talking about the motivation for frequency domain stability and identifying the gain and phase margins. And so it's interesting to then connect those gain and phase margins to the Nyquist plot as well. And so we're gonna see how visually the gain and phase margins show up on the Nyquist plot. And so the phase margin, for example, is identified where the magnitude is 0, or the magnitude is 1, so it's 0 dB. And we're going to find that frequency value and identify how much extra phase we have beyond 180. So we measure it from minus 180 up to the phase curve. And so if this is the magnitude and this is the phase, then this is the corresponding real and imaginary value. And so here we look for this dashed blue line indicates magnitudes of 1, and so that corresponds to points in the imaginary and real space here that have magnitude of 1, so 0 dB. And so the point where that crosses the actual curve for the system, the Nyquist curve, is right here. And so then that means that the phase margin is the amount that the phase exceeds minus 180. So this is the angle minus 180. And so if we measure from that up to this point, that gives us our phase margin. So then to identify the gain margin, what we do is we find the frequency value for which the phase is minus 180, and we measure how much the magnitude is below the 0 dB line. And so the way that we find that is this is the angle of minus 180 along the negative axis, real axis here. And so where that crosses is going to give us our gain margin. And so this is now not in decibels. And so what ends up happening is this distance from, that is the magnitude, right here, that is 1 over the gain margin. And so why that is, it's useful to kind of think through this. So if we call m the magnitude, and so that magnitude is, so that's, maybe I'll just say m, which is the same thing as magnitude of g of I omega. And that is, we'll call that 1 over the gain margin. And so to show why this shows up and is exactly what we're diagramming here, we're going to go ahead and figure out what the dB magnitude is. And so the dB magnitude is 20 log of m. And so that's 20 log of 1 over the gain margin by our definition from here. And so if we use our log rules, we can rewrite that as 20 log 1 minus 20 log gm. And this ends up being 0 dB, and this is just the gain margin in decibels. So I'll call it gm sub dB. So this is 0 decibels minus the gain margin in decibels, and so that's exactly what we're measuring here. So we're saying if this is the gain margin, I'm taking the magnitude itself is 0 dB minus this gain margin. And so that's why we define this as 1 over the gain margin. So this is a way of identifying both the phase and gain margin from the Nyquist plot.